Hello. We started hypothesis testing in the last lecture, and I introduced how it works. And the framework for the hypothesis testing is quite weird. It's seemingly unfair and unneutral. And that's right, but it is not unique. The framework is common in our decision making. So I used several examples. One was the presumption of innocence in the modern legal system. So when you determine if the dependent is innocent or guilty, it's not a fair comparison. So because without any evidence, you have to believe that the defendant is innocent, and then if there is enough evidence, then you have to turn the decision to guiltiness. And paradigm shift, it's similar in the science, in the history of science. There have been many revolutions, scientific revolutions, but every time the incumbent existing hypothesis, existing theory was believed, even though it had some contradictions. But when the contradictions accumulate and more observations accumulate, later at some point there was a revolution, and the theory is replaced by a new one at a certain point when the evidence against the existing theory is sufficient. And third example I gave you was conservative decision making. So you say I use this say grocery mart. I use one grocery mart, but I heard that another grocery mart is better, cheaper. But maybe inertia, or the people tend to use what they used to use. But at a certain point, if you get more information about better options, and if you hear more reviews, your recommendations about another brand, then you may change your decision. So you change your decision only when you have enough evidence for that favor new choice. Otherwise, people tend to use what they used to do. Similarly, we have statistical inference in hypothesis testing. The null hypothesis is a hypothesis that is believed without any evidence. So without looking at the data, we believe that the null hypothesis is true. Or we would like to, it's like existing theory. It's the incumbent hypothesis. So it is favored, it's believed, until it is proven wrong. So then, given the null hypothesis, the challenging theory is the alternative hypothesis. So you collect more data, and if you find that the collected data, the observed data, are inconsistent with the null hypothesis, too much inconsistent with the null hypothesis, then only then you are going to reject the null hypothesis. Otherwise, you do not reject the null hypothesis, even if it's uncertain, even if there is no clear conclusion. That's the framework of hypothesis testing. So there are only two results, only two decisions as a result of the hypothesis testing. One is rejection of the null hypothesis, the other is non-rejection of the null hypothesis. So I empathize that rejection is a strong conclusion, but non-rejection is not a strong conclusion, because when you cannot reject the null hypothesis, it may be that there is just not enough evidence. So when the data is somewhere in between the null hypothesis and the alternative hypothesis, then still we take the null hypothesis. So it's weak. But when you reject the null hypothesis, that means the data, it's clear that the data are inconsistent with the null hypothesis. So, I will so given the framework and the way of thinking, I am going to think of another detailed example to think about how we reject the null hypothesis statistically. So that's what we are going to learn in this example. So the example was airline cancellation, free cancellation policy. So suppose that airline allows free cancellation of reservations, and they know that the company knows that one reservation can be canceled with 20%. However, there may be some abusers who make a lot of reservations and cancel all of them. So then the company is trying to identify those abusers and try to ban those abusers from making reservations again. And here I consider two suspicious customers. Say, so one customer made 5 reservations in the past, but canceled 3 of them. And there is another customer who made 100 reservations and canceled 30 of them. So then how can you tell, or if you compare these two, if you compare these two customers, who is more likely to be an abuser, or who is more suspicious? That was my question. And so many of you may think it this way. Customer A canceled 60%, and customer B canceled 30%. So higher probability will imply more suspicious, more likely to be suspicious. That makes some sense, but if you look at this more carefully, then I would choose customer B the other way. Customer B is more suspicious, and according to the following rationale. So let me explain how we compare them. What we are going to do here is we are going to use the binomial distribution, because we learned this reservation and cancellations is a clear example of a binomial distribution. So I calculated the distribution of the number of cancellations when a customer makes 5 reservations. When a customer makes 5 reservations, if they have no bad intention, they are not abusers, then still they may cancel it with 20%. So then you get distribution like this. What's interesting here is what you have to understand here is, even if the probability is 20%, and even if the customer is not an abuser, still he or she may cancel all the 5 reservations with a small probability. So anyone would think if you cancel 5 out of 5 times, anyone would ban this guy. Anyone would think this is an abuser. Right, I agree. But so it means that first, what you have to understand here is, in statistics, we are studying statistics, there is no sure thing here. So everything is possible with small probability. It's just unlikely to happen because the probability is too small. So then our decision is we are trying to identify abusers, and we are going to ban those likely abusers. But as a byproduct, some of them would not be abusers. Some of them would be innocent customers. Still, it's a trade-off. So we cannot exactly identify who is an abuser, but we just ban those who are most likely or most suspicious to be an abuser, right? First, it's understand that there is no 100% certain abusers, like observationally on the data, because it is possible. But still, we can rank the suspiciousness, how suspicious they are. So if you cancel 5 out of 5 times, there are 0.03% innocent customers, and like 0.64% are innocent but cancel 4 times, right? Like this. Then, as I said, it's up to you where you how much you are going to ban. So if you ban, for example, if you ban the customers who canceled 3 times or more out of 5, then in the end you are going to ban 5.79% of innocent customers, right? So if you set the cutoff at this point, you are going to like there is a collateral damage of innocent customers as much as 5.79%. This is so in other words, if you put a threshold cutoff here at this point, this is the probability of more suspicious customers than this guy. So this is the ranking of this customer. So this many customers are more suspicious, more likely to be an abuser than this customer. So we may understand this probability as a kind of ranking of suspiciousness. So you can rank all the 100 customers from the most suspicious to the least suspicious, and you are looking for where to cut. So you are going to ban a certain amount of customers from the most suspicious, from the top rank, and at depending on where you cut, you are going to get some probability, the ranking. Now we are going to consider 100 reservations case. Previously, we considered 5 reservations, so we had this distribution. I explained, by the way, this in the last lecture. I just did it again, just to remind you, because it's continued in this case. So now let's think about a customer and a group of customers who made 100 reservations, right? Like innocent customers who made 100 reservations. Again, it is really unlikely to happen, but still there is of extremely small probability at this point. So probability of cancellation is 20%. That can happen 100 times in a row. Super unlucky. I have 100 straight, 100 accidents whenever I made a reservation for flights, for example. So that is extremely unlikely, but possible with very small probability. And obviously, if there exists such a customer, that customer would be the most suspicious customer. It's hard to it clearly anyone would think that guy is an abuser, right? So again, it's a matter of where to cut. Like say, for example, if a customer canceled 50 times out of 100, then how suspicious? We are going to calculate the ranking in the same way. Let's think about this way. What's interesting here is there is because there are 100 reservations, so almost all probability is concentrated in here. Most of the probability is in here, and so the sum of all the probabilities at 30 or above is only 1.12%. I said the probabilities here are really, really small. So their sum is only 1.12%. Right? This is, again, we may interpret this as the ranking of suspiciousness. So customer B canceled 30 times out of 100. And that is top 1.12%. So again, if you think about the ranking of suspiciousness, customer B is within like top 1.12%, which is very, very high. Previously, customer A was within only like 5%, like 6%. So the probability is, so customer A is, in this sense, customer A is less likely to be an abuser, less suspicious than customer B, right? That's the reason why I think customer B is more suspicious. I'm going to explain this. I'm going to continue this explanation in the next video. I'll see you in the next one.